Hi, in this video I will be showing you problem number 20 of chapter 15 section 6. Use a triple integral to find the volume of the given solid. The solid enclosed by the paraboloids y equal to x square plus z square and y equal to 8 minus x square minus z square. So let's underline the keywords. One is to use the triple integral to find the volume of the solid. The triple integral to find the volume of the solid. The solid is made up of two paraboloids. One is y equal to x square plus z square. The other one is y equal to 8 minus x square minus z square. By looking at the two paraboloids equations, we are able to say both have y isolated. So the axis of the paraboloid is directed towards the y direction. The first one, y equal to x square plus z square, is opening right. The other one, y equal to 8 minus x square minus z square, is opening left. So as we draw the diagram of this surface, we will understand this picture better. So first, how do we apply the triple integral? So just as the way we did double integral to find the area of the domain, we can use the triple integral to find the volume of the solid. The formula for volume of the solid is triple integral over E 1 dV, which is V volume of the solid E, V of E. So here we are making the height of the surface equal to 1. So using the triple integral, we get the volume. Next, let's analyze the graph. So how does the solid look like? So let's graph that in the three-dimensional coordinate system, x, y, z axis as shown here. We need more information where the two graphs meet, where the two surfaces meet, and so on. So let's have the negative x-axis, negative z-axis, negative y-axis shown as here. Then the two paraboloids, y equal to x square plus z square and y equal to 8 minus x square minus z square, both of them have the axis. One is opening to the right, the other one is opening left. The axis of the paraboloid is the y-axis. Now, where do the two paraboloids meet? Where do they intersect? So let's set the two y's to be equal. So x square plus z square equal to 8 minus x square minus z square. That will give us 2 times x square plus z square equal to 8, which means x square plus z square equal to 4. So they meet along a circle with center at the origin and radius equal to 2. Which plane is it? X square plus z square equal to 4. So if you plug it in here, so you get y equal to 4. So they meet along a circle x square plus z square equal to 4, center at the origin and radius 2, on the plane y equal to 4. Okay, now the two paraboloids meet in a circle x square plus z square equal to 4 on the plane y equal to 4. So now we have some idea about the graph. So let's go ahead and graph this. So 4 is where they meet. So I need that 4 on the y-axis. Then draw lines parallel to the y-axis and the x-axis and the z-axis at that point 4. Then we know that they meet on a circle x square plus z square equal to 4. So along the x-axis I have marked 2. and they meet at that circle. One is an open upward parabola, which I've shown as red here, and then the other one is open to the left parabola. And because it's the equation is 8 minus x square minus z square, it's going to cross the y-axis at 8. Because if you plug in x equal to 0 and z equal to 0, you get y equal to 8. So that parabola, the paraboloid, second one, crosses the y-axis or has the vertex at 0, 8, 0, because it cuts the y-axis at 8. Right? So the red one is the open to the right paraboloid. The purple one is open to the left paraboloid. They meet at the circle x square plus z square equal to 4, which is parallel to xz plane along the plane y equal to 4. Now, what is the projection of this? Because we need the domain, right? What is the projection of this disk? X square plus z square less than or equal to 4 on the plane y equal to 4. We have to project it on the xz plane, on the plane y equal to 0. So I've drawn this. It's only a rough sketch. It's not beautiful, but hope it makes the point clear. So you project it along the xz plane. So you get a circle similar to the one that is shown here, which is x square plus z square equal to 4 on the plane y equal to 0, which is the xz plane. That is a projection. Now the red one is y equal to x square plus z square. The purple one is y equal to 8 minus x square minus z square. And then they intersect at x square plus z square equal to 4 on the plane y equal to 4. So now we have all the information to compute the triple integral for the volume. So we get solid E can be described in terms of x, y, z as follows. So what is solid E? So it is made up of x, y, z, where the projection is a disk, and the y lies between the left paraboloid to the right paraboloid, which is x square plus z square to 8 minus x square minus z square. And the domain is x square plus z square less than or equal to 4. So let D be that domain which consists of all those xz such that x square plus z square is less than or equal to 4. We have seen earlier problems where when the disk is the domain, then it's very easy for us to compute using polar coordinates. So it's good to know that the domain in this problem happens to be, or the projection happens to be a disk. Projection of the intersection on the xz plane is a disk. As the domain on the xz plane is a disk, we can use polar coordinates. X equal to r cosine theta, z equal to r sine theta. Now, the triple integral v is triple integral over E dv, which is double integral over the domain, and then y ranging from x square plus z square to 8 minus x square minus z square. So that becomes an inner integral with respect to dy, with respect to y. And then outside we can write area of the domain, or dA. So which is v, with the double integral, this domain can be replaced by x square plus z square less than or equal to 4. And then this dy on integration is y. At the upper limit, it is 8 minus x square minus a square. The lower limit, so subtract at the lower limit, which is x square plus a square, followed by dA outside. If we simplify the inside, so it's going to be 8 minus 2 times x square plus z square, 2 times x square plus z square, and then outside you have dA, which is the area of the disk. So we can use polar coordinates at this point. So it's integral 0 to 2 pi integral 0 to 2, because theta runs from 0 to 2 pi, r runs from 0 to 2, because the radius of the circle or the projection is 4. Radius is 2. Radius is 2. So 8 minus 2r square times this dA can be replaced by r dr d theta. Simplifying, we get integral 0 to 2 pi d theta, then integral 0 to 2, 8r minus 2r cubed dr. Here we were able to separate theta and r because one is independent of the other. So v equal to theta running from 0 to 2 pi, and then if you simplify the other integral for r, it's 8r square over 2 minus 2r to the power 4 over 4 between the limits 0 and 2, which is 2 pi times, if you simplify that, it's 16 minus 8, which will be 16 pi. So the volume of the solid is 16 pi. Hope this video helps.